In our previous video, we looked at matter and how matter can be classified. And you may recall that when we started this course, I told you that a simple working definition of what the subject of chemistry is all about is the study of matter and the changes that matter undergoes. So now that we understand how to classify matter into different categories, let's take a look at the two major types of changes that matter can undergo and the properties that are associated with each. So looking at the board here, we see the first category is physical properties and physical changes. One type of change that matter can undergo is a physical change, and that's closely linked with its physical properties. So a definition of physical properties is characteristics of a substance which can be observed or measured without changing the identity or the composition of the substance. In kind of speaking in somewhat colloquial language, you still have the same stuff when you are looking at a physical property. You can measure it and still have the same stuff present as you make the measurement or observation. Examples of physical properties include melting point, and I'll refer to that throughout the semester and just abbreviate MP, boiling point, BP, density. We've discussed what density is and we've had a lab on measuring it, as well as solubility, color, odor, and there are other examples, but this gives you an idea of what we're talking about. The process of measuring or observing all of these different properties does not involve us changing our substance into something new, different. It still has the same composition as we make these measurements or observations about the substance. So we call these physical properties. Physical changes are closely linked with physical properties. A physical change is the change in the form or appearance of a substance that does not change its identity or composition. In other words, you still have the same stuff present at the end of the change, end of the physical change. So melting point, boiling point, these are discussions of changing the phase of matter, say from a solid to a liquid or from a liquid to a gas, but you still have the same substance present at the end of that change. So boiling, vaporizing is another term to describe this process. Freezing, melting, all of these are phase changes, converting from solid, liquid, gas, or vice versa. Dissolving, closely linked with solubility, breaking into smaller pieces. You still have the same substance. It appears different because it's now crumbled and present in smaller pieces. An example of how to write a physical change is listed up here. We see water, very familiar substance, H2O, and it's in the solid state abbreviated with the subscript S. And we can take water, like an ice cube, and observe that it can melt. The melting process causes a change in the appearance of the water as it converts to the L or liquid state, but note the hallmark here of a physical change. You still have the same stuff, still have the same substance, I can say that. Still have the same composition, 2 hydrogen atoms bonded to 1 oxygen atom present at the beginning of this change as you do at the end. You did not change the identity, just the form or appearance, but not the identity. And melting is an example of that. Let's transition to the other major type of change, and that's chemical change, closely associated with chemical properties. So if you are talking about a chemical property of a substance, you're referring to characteristics which describe the ability of a substance to change into a new substance with new chemical and physical properties all its own. In other words, you no longer have the same stuff present at the end when you're talking about a chemical property. as you did at the beginning. The process of observing this involves a change to produce new substances. Examples of chemical properties are flammability. Can a substance burn? And the burning process, as you observe it, you're seeing a substance change into a new substance with new properties. Another example of the chemical property is rustability, more technically known as can it be oxidized or oxidizability. So you know that an iron nail, if left outside, will slowly change appearance because it is undergoing an alteration to form a new substance. The rust-colored substance on the outside of the nail is not the same composition as the iron nail itself. So rustability, another example of a chemical property. Chemical changes very closely correlate. A chemical change is the conversion of a starting substance, or substances plural, more than one, and these starting substances are called reactants. So the conversion of reactant substances into some new substances, which are referred to as the products. The products have a different chemical composition than the reactants, different identity, therefore different properties, both physical and chemical. And this is an important note. All throughout the rest of this semester, we're going to be using the word reactions, chemical reactions. A reaction is another term for a chemical change. So all chemical changes can also be called chemical reactions. And you see I'm noting this abbreviation here right at the end. We use the term reaction so often that we abbreviate it RXN. And here is an example of how you note or present a chemical change. So in this example, my starting substances, I'm giving you their chemical formula. This is methane, the major component of the gas that runs through a Bunsen burner. And so we know the gas that is present in the Bunsen burner when we turn that gas line on is very flammable. So methane, one of its chemical properties is flammability. That means that it will react with oxygen in the air, and in this reaction, we have a conversion of these substances into totally new substances that we call products. We totally break apart chemical bonds and rearrange atoms and form new substances, which we can identify are also compounds. So carbon dioxide and water are the products of the combustion of methane with oxygen gas in the atmosphere. And notice, a reminder, I've indicated that oxygen is a diatomic element, one of the group that you're asked to memorize. So we form new substances, new products, carbon dioxide, and water. Last thing I want to do before I leave this example is to note that it is not balanced, meaning that we haven't accounted for starting atoms and made sure that they are equal to ending atoms. Atoms don't just appear and disappear. We have to have the same total number of atoms present on the reactant side, the starting materials, as we do atoms present in the product side. So doing a very quick inspection, I can see that methane contains one carbon atom. There are no other carbon atoms in the reactants. And the products, carbon dioxide also has one carbon atom present in it. So my carbon count is balanced, reactant and products. One carbon on the reactant side, one carbon on the product side. But it's a different story with hydrogen. I see here that there are 4 hydrogen atoms bonded to one carbon atom in methane. But here in the products, water is the only compound that has hydrogen, and it only has 2 hydrogen present. Now we cannot change that 2 to a 4 to balance. Water is not H4O, it's H2O. But we can do this. We can put what we call a coefficient in front of the water, and now I'm talking about 2 water molecules, not just 1. And 2 water molecules would contain a total of 4 hydrogen. 2 times 2 is 4. So I now have balanced the hydrogen atoms on both sides of this chemical equation. This notation of a chemical change is called an equation. The last thing I have to do is balance the oxygen atoms. So there are 2 oxygen atoms in carbon dioxide. 2 times 1 is 2 oxygen atoms present in 2 water molecules. So 2 plus 2 gives us 4 oxygen atoms on the product side. And I'm going to come over here and write a coefficient 2 in front of my oxygen molecule. And 2 times 2 is 4 oxygen atoms now on the reactant side. So I have balanced this chemical equation and accounted for where all of the atoms in the starting substances, also called reactants, end up in our products. Our atom count is equal.